explain how that happens a bit later. And maybe a new state gets, like a new machine gets created and it's put in a new state that you've not used before. So you put in another finger, a new finger on that state, and so on. It doesn't have to be fingers. You could have little markers. You could have little pins, or anything. Some indicator that that particular state, one of these four, one or more of these four, is active in a sense. It's there is a machine at that moment in that state. Okay, the ones that you're pointing to with your fingers, or you've marked with pins or something. Okay. All right. Well, now we're here. Let's say so we're still in Q1 with our finger on it. Let's say in Q1, and now we read the second symbol. It's a 1. Okay. Now we've got, and there are no eters. Remember that. Check that each time you get to a new state. Check that state does not have eters, because if it does, you'll have to create a copy and put the current state of that copy, what the eta arrow points to. Okay. Okay. So anyway, so we're here, and now the second symbol comes in, and it's a 1. So we have a choice. We can either go to Q1, right? So Q1 goes to Q1. That's this. That would correspond to this arrow, this transition. Or we can go to state Q2. Okay, so that would correspond to this one. Okay. Now, because we had two choices, we can go here or here. That implies a splitting, non-deterministically. Okay. So we now have two machines. One of them will stay in state Q1, but if we go, that's if you take that transition. But if you take this transition, the second machine will be in state Q2. Okay. Now, every time you go to a new state, check if there's an eta from it. Well, there is here. Look, there is an eta. So immediately create another machine and put its current state in the state that the eta is pointing to, which is Q3, and here it is. Okay, so bam, we've gone from one machine, one state, to 3 machines in 3 different, and they happen to be in 3 different states. Okay, so now we're here. Now, so you can put your finger. You put one finger here, one finger here. Oops, hold on. One finger here, one finger here, one finger here. So sort of like that, right? Now, if you find that inconvenient, you have to use fingers. You could use pins or something, coloured pins, like red pins. So you could stick a pin in here, here, and here. And remember, so that means that those 3 states are active in 3 different machines, 3 different copies of your automaton, your NFA, and those 3 machines will just process independently, right, from now on, as you go down step by step, as time goes this way. All right. Okay, so I was talking about fingers. We talked a bit about that, right? So there is an eta exiting from here. There it is there. So when we transition from Q1 to Q2, a Q2 machine got made, but there's an eta, so a Q3 machine also got made at the same time. You don't have to wait for the reading of the next symbol when you're talking about an eta. That's the difference. That's why it's a little bit tricky. So I hope you followed me on that. Okay, so all right. So we've got now 3 fingers, or 3 pins, if you like, on these 3 states. So that's pinned, or fingered, same thing. That's pinned, that's pinned, that's pinned. Now, for the next step, now you read in then you're reading in a 0. So you read in the 3rd symbol. Okay. Now, each one of these that is fingered, the states that are fingered, you analyze each one separately, one by one. Okay. So then, so this one's pinned or fingered. So is this one. So is this one. So have a look at this one, and the input symbol is 0. So what do? Well, it's deterministic, right? We have to go to Q1. So this Q1 will just go to Q1, right? No choice, because there's no multiple labels that are of the same value, right? There's only one 0, whereas there are two 1s. Okay, so that Q has no choice. It deterministically goes to Q1. Okay, now that one's also fingered or pinned. So Q2, what does it do? Now the input's 0, right? No, I'm just hesitating. Why? So I guess the eta has been used now. So that eta got used when you transition from here to here. I'm a little hazy on that. But because look, he's not split. Right. Can you see this Q2 here? See, we analysed that one. It just went to that. And these three are pinned or fingered. So now we're analysing this one. What will Q2 do? What will the machine in state Q2? What will it do? Well, and the input symbol is 0. Well, it just goes to Q3. So Q goes to Q3. Now, what about the zeta here? I guess that only operates on the previous one in a sense. That's my interpretation. Like I say, these zeta things are a bit tricky. All right. Well, we'll see what I've just said is valid. Okay, so Q2, and this diagram straight out of the textbook. So it takes a bit of study. The NFAs are more subtle, thanks to these eta things, than the DFAs. Although later I'll be contradicting that. In some cases, many cases, an NFA is actually easier to understand. It involves less states than a corresponding DFA. In fact, well, jumping ahead a little bit, I can tell you now, for any NFA, you can prove, and we will later boards, for a given NFA there is a corresponding DFA. In other words, for each non-deterministic FA, finite automaton, there's a corresponding, does the same thing, DFA, a deterministic finite automaton. And you might have what seems like a fairly simple NFA, and then you calculate, because there are ways of doing this, you find its equivalent, meaning having the same function, does the same thing, recognizes the same language, in other words. But typically you'll have a lot more states and very complex, compared to the relative simplicity of the NFA. And how many sessions? In two more sessions, I'll give you a concrete example of an equivalent DFA, and you'll see just how much more complicated it is than its corresponding NFA. But jumping ahead a little. So, okay. Okay, so down here we've got 3 fingers on these. We've done that one. Q1 to Q2. Q2 went to Q3. A bit of a query about this eta. I guess it got used here because this Q2 only goes to Q3. There's no splitting, right? And Q3, what does Q3 do? Well, here. This is now interesting. Now notice here there's no successor to Q3. This branch here died. Now why? Why did it die? Well, now this one's fingered or pinned. Okay, this state here. The input symbol is 0, and the only transition from this state is labeled 1. There's no label here of 0. When that happens, your state and your machine, the machine in that state dies. It just disappears. And that branch, the branch that machine is in, terminates. Right? So it stays here. It's just not there at the next step. Right? So this one has died. So now we have two machines, two branches. This third branch here died.